Hello, welcome everyone to another episode of the Virtual Ninja Show. As organizations scale agentic AI, it's not about creating new agents, it's actually more about how to secure and govern the data they access. And that's why I have Innocent with me, a returning guest. Innocent, please introduce yourself.
Thanks, Heike. Good to be back again. My name is Innocent. I'm a product manager with the Purview for AI customer experience engineering team, and we help our customers integrate between Purview and agent building platforms so that they can benefit from the security, governance, and compliance features that are already available in Purview.
Yeah, and as I mentioned in the intro, right, it's super critical to help our customers secure all the AI that they're building and using across the different platforms. So how are we doing this? Let's get right into it.
Indeed. So as you say, so customers should not be restricted, and they are not restricted to the platforms that they can build agents on. But as we said earlier on, the bigger challenge is not necessarily to build agents. I'm sure you agree with me that it's not that difficult to build an agent. But in an enterprise setting, what's more important is, are those agents secure from the standpoint of the data that they access? Are they putting the organization's data at risk? So what Purview brings to the table is to say, we have developers on the one hand, and we have the data security practitioners on the other. How do we ensure that we have this central policy definition engine that evaluates the prompts and responses that are coming and going into those agents, making sure that the data of the organization is not at risk? And that empowers developers to focus on building very cool agents by not having to bother about, okay, how do I code for security? How do I build for security in this platform, the other platform? With Purview, we can centralize that policy evaluation, the policy governance in one place, and the agents can be built wherever they are, so long as they point to this central policy agent.
Is it looking at the prompts, or does it have a repository and will then review what the agent's permissions are, or is it a combination of everything? So how are we looking into the access permissions of agents?
Purview has been around for a long time, looking at the classic data security challenge. So you would have things like policies that define who can access this data, who cannot. So we have extended that to cover this new age of generative AI, where we have this construct of prompts and responses. So what happens is that we define the policies in this central place within Purview and say, this user is not allowed to see this type of sensitive data. They are not allowed to put this type of sensitive data into a prompt that could potentially leak the organization's sensitive information. So you define policies within Purview, and then when the user is interacting with the agent, those policies determine what data they can see. So if there is sensitive data that might be going into the agent or into the large language model, then Purview is going to step in and intercept it and prevent it from being sent. If feedback is coming back or a response is coming back from the agent, and it contains some sensitive data, Purview is going to make the determination again by evaluating the policies and checking, is this user allowed to see this sensitive data? Because there will be cases where certain roles within the organization are allowed to see some content and others are not. So the policy really is based on the user's identity and their groupings and all that to determine, can they see this type of information or not?
So an agent also can get assigned an identity, right? So we have, for instance, intra-agent IDs. And now the policy applies to that identity being used of the agent or of the user using the agent?
Yeah, no, that's a good question. So I haven't seen scenarios of the agent itself being assigned a policy, but that is potentially possible because, yes, the identity is in Entra. And so long as it's a valid Entra ID, it can be assigned a policy. But typically, the scenario is mostly around a user that is interacting with an agent. So we are basing the policies on that user. But it is technically possible to do that because you can identify that agent within Entra ID with its unique user, and you can provide or you can assign policies to it that would restrict it.
Wow. So Innocent, basically, customers can create agents wherever they want, and we govern from the Purview side of the house. That's right?
That is correct.
Okay, so I think I'm curious to see this in action.
Oh, absolutely. Glad to show you. So let's start at home with the Foundry integration. So Microsoft AI Foundry, to integrate Foundry with Purview is pretty simple. What you would do is to come to the Operate tab and then go over to Compliance. Once you're there, you go to Data Security and Governance. And then what you're going to see is this toggle. Of course, it's going to be off if this is the first time you're doing it. So you would turn the toggle on, and what that would do is that it would now connect Foundry with Purview, meaning the audit events in Foundry will start streaming into Purview, and then we can start to do our management on that side. So to do this, you need to have one of two roles. So you need to have the Foundry account owner. That's one of the permissions that or roles you need to have to be able to perform this operation or this integration. Or you also need to be a subscription owner. So this integration happens at the subscription level. So once you've done that, then the integration is complete. Next is you can start to interact with your agents. I've got 3 agents here. The one that you will see in the portal eventually, you'll see its events is this HR policy agent. So on the Foundry side, it's pretty much straightforward. But we are here to talk about how you can do this, not just for our first-party agent building platforms, Foundry in this case, but also third parties living in other clouds. Could be AWS Bedrock, which is what we are going to see. It could also be on Google Vertex AI. You can also integrate with agents that are built on that platform. So before we go into the AWS demo, let me just set the stage here with a quick slide that will walk you through the architecture. So when we get into the weeds of the code, it's going to be much easier to understand. So it starts with the front-end application. So there is a single page application that's just specifically designed to simplify that interaction between the end user and the agent and the infrastructure that's behind it. So the purpose of the front end is simply to allow the user to log on and then submit test prompts and see what happens. In this stage, what's important also is that we are taking advantage of the Microsoft authentication libraries. So that helps us with the token management, which can be complicated, but is simplified by the MSAL. Next thing is that we have an application registration. So the reason we have this is so that we can be able to have the application act on behalf of the user and submit the prompts and interact with downstream services like Purview and the AWS components. So we have the application registration done within Entra, and we're going to see that in a moment. And what it also does, it does that on behalf of token exchange. So it takes this user token and exchanges it for one that can be used to make calls to the downstream services. The first one being the AWS infrastructure. So within the AWS infrastructure, we have the API gateway, and this is a gateway that receives the prompt from the front end and then submits it to a function within AWS. So AWS Lambda, this is the one that now does the submission of the prompt eventually to the Purview middleware and policy engine to have it evaluated and to determine whether it is admissible or not. We have a secrets manager within the AWS infrastructure. What it does is that it stores the client secret from the app registration that is used to authenticate the application when it attempts to make a connection with AWS. And then we have, of course, CloudWatch is just a backend service there that is collecting the logs in the AWS side, tracking the activities there. On Purview, this is where now the middleware comes in. So here we are using the Microsoft Agent Framework SDK that allows us now to have this simplified way of integrating between Purview and third-party agent building platforms. So all that developers need to do is to code with a few lines of the Purview middleware, and that helps to make it that simple to be able to say now, when a prompt is submitted to this agent, this is what happens in the backend without necessarily going into the details of coding for data security. What would happen is that it would now redirect those prompts to a Purview for the evaluation. And that's what's happening in the next step there. So the DLP policy engine, the middleware is going to package the prompt into a message object, send it to the DLP policy engine. And this is where those policies that have been defined will be evaluated and to see, are they applicable to this user or not? If they're applicable, then we are going to have the appropriate response, whether it is blocked or allowed. And when all this is happening, the outcomes of those transactions are now sent to the audit log, which will eventually be presented to the data security posture management that will see where the data security admins can look at the activity of what's going on with their agent as it's being used within the organization. On the infrastructure level for the large language model and the agent, we've got a simple model there, Nova 2.1 Lite. And then at the bottom, you see the end-to-end flow. So user logs on, the on behalf of token exchange happens, they submit a prompt. Then this is where the Purview middleware comes in and intersects that prompt. It examines it and then sends it to Purview to evaluate it for whether it should be allowed or not. Does it contain sensitive data or not? If it's allowed, it goes through. It goes to the second gate. So there are 3 gates here. The second one is actually the model itself. So models also come with their own layer of security or safety. So there would also be some checks there that AWS Bedrock would do independently. And if it allows that prompt to proceed, then it's going to reason over it, generate a response, and now send it on its way back to the user. There's going to be yet a second check by the Purview middleware. So now this is on the way out. We also need to check to verify that whatever the model has generated does also not contain sensitive data. And if it does contain sensitive data, is this user allowed to see it or not? So if that gate is passed, meaning Purview allows that response to reach the user, then they will see the outcome on their UI. So that is the end-to-end journey that the prompt takes in this scenario.
So, wow, I don't think anyone has explained it that well before to me. Thank you so much. But I have a question. So you said that for the Purview middleware, does it mean the developer of the agent need to add specific code to the agent so that this thing works?
100%. And that's the encapsulation we do for the developer. So all these complexities of send this prompt to Purview, get it back, and then decide what it is all taken care of within that middleware. And typically it's about 10 lines of code, which we are going to see in a moment, but that's exactly it. It's kind of an abstraction of saying you just use this particular piece of code, and that code is going to take care of all the plumbing of sending that prompt to Purview, getting the response, bringing it back, and determining is it allowed or not. That's exactly the benefit we are giving to the developer on the one hand. And on the other side, the data security practitioners, they don't need to worry about where is this agent being built. They just govern and do their protection policies in that one single place.
And do we have something that helps developer know that this is required, and also for the organization ensure that all the agents that are being built include this?
So this is a policy that the organization will put in place. They will make it a requirement within the organization that for an agent to be admitted into production, it has to go through this governance process. And then they would provide them with a guidance.
And the toggle that you turned on in Foundry, was that connected to that policy?
No, so that was to show you the Foundry platform. So we are looking at two different platforms here. The first one was showing you that how easy it is to do it within Foundry. And that is one agent platform. It is our first-party platform. You can expect that the integration be that straightforward. We are now showing the AWS one to showcase that we have the central policy engine. The same integration we were doing with Foundry was to integrate it with one instance of Purview. So that same instance of Purview is the one we are also reaching with this middleware that is now embedded within an AWS Lambda function, a Python code within the AWS environment. And this could also be done in Google Vertex AI. That's another agent building platform. So long as you are building with Python or .NET, you can use the SDK. If you're building with any other languages, then you can use the Purview APIs. That can also allow you to build on any platform that you can have access to, but still use the APIs to reach that single instance of Purview. So that's the key thing here.
So now it's Innocent that you actually explained what we are going to look at.
Yeah.
Let's have a look into how it really looks like from a code and everything. That's super interesting.
Yes. No, absolutely. So it begins with the application registration. So remember from the slide, we saw the app registration, which you need to do that delegation from the user to the app so the app can call services in AWS, in Purview on behalf of the user. So this application needs to be registered within Entra, and it needs some specific permissions. So first one is content process. Also, this permission is what allows it to actually do the evaluation of the policy. And then the content activity.write, this is the one that actually writes the outcomes of those evaluations. So the audit logs, it updates the audit log based on what happened with the evaluation of a prompt. Then we have the protection scopes compute.all. This is the one that actually looks at the tenant to check what policies are available and applicable at the tenant level. And then this second one here, protection scopes compute.user, is looking at what are the policies that apply to this logged on user so that we can check, are they allowed to submit this type of prompt? Are they allowed to see this type of response? So these are the 4 permissions that need to be given to the application as you do the registration within Entra. Now let's look at our Bedrock agent itself. So here it is. We are within AWS console here. A simple prompt here to prove that the agent actually works. So indeed, it does work. So that's our agent. Now let's look at the code that's powering this agent. So here we are. This is the Lambda function itself. At the beginning here, we are just looking at importation of the modules and the Purview middleware itself. That's what is actually happening here. So within the agent framework, we have the Purview middleware defined in there. So this is the important step of bringing that in.
But that's all. So basically those couple of lines at the beginning and then a couple of lines in the end.
Not yet. This is just to bring in the modules. It's to set the stage and make sure that we have all the dependencies in place. Don't rush. Okay, so we are going to get there in a moment here. I just want to ignore all the other infrastructure bits there and get straight to the first gate. So again, back to our slide. Remember, we had multiple gates, starting with the first gate where the prompt has been submitted to Purview. The middleware is intercepting it and packaging it as a message object. So this is what is happening here. And a message object basically involves the person sending the prompt and the content itself. So this is actually the code that we were talking about, the minimum middleware that's needed. So in this case, we are looking at the prompt going towards the model, and that is considered an upload text activity. Now here we have put together the prompt itself and the user ID, because remember, the policies are evaluated on a per user basis. So we want to see, is this user allowed to send this type of prompt? And then the evaluation happens. It's sent to Purview in the backend. As you can see, you don't even see that kind of happening here. It's all abstracted by the middleware, but the prompt is sent to Purview. Purview evaluates it and gives a feedback or a verdict. So it's either blocked or allowed, and then the appropriate message is presented to the user in the UI that we'll see in a moment, telling them the prompt was blocked, or if it was not blocked, it's allowed, and it goes to the second gate. So the second gate is a model itself. Remember, the model does have its own controls, so it can choose to actually reject the prompt at that layer, depending on what's been configured. But if that passes through the model layer control, now the model is going to generate the response and then send it back towards the user. Again, the Purview middleware is going to intercept it. And now we are looking at an activity of download text. So from the API perspective, the download text activity is like now the response that has been generated. And then the middleware does the same thing here. It packages the message object. And this time, the role turns from user, as you saw up here, to assistant. The reason is because the first time when we were sending the prompt, the user is the one sending the prompt into the model. Now, the model has reasoned over the prompt. It is generating a response, and now it takes the role of assistant. You could change this and put in agent. So that's the same thing. So the only difference here is that we have an assistant here, and we have the activity being download text or response. So again, we are passing the user ID to make sure that the user is allowed to see this type of response or not, because as I say, there could be cases where a user is allowed to see certain content because their job requires them to do that to help a customer or something like that. There are others who are not allowed to. So again, all based on the policies that are defined, which we shall also see in a moment. So if it's blocked, same thing happens here, or allowed, the user is presented with the appropriate message in the interface. And here's the interface. So log on to our front end here. Again, you saw that in our nice, cute slide earlier on, that this is where we begin the transactions. We log on to the browser front end, and we can start doing some testing using some canned prompts that we have down here to make it easy to do so. So we asked the first one, was pretty straightforward. It went through, no issues. And then we decided to get cheeky and put in a credit card. It's a fake credit card. As you can see, it got blocked. And then we said, let's try our luck again with a social security number. Tried it, and again, it did not go through because Purview is doing its job. All right. Let's see now what happens in the Purview side. So it begins by turning on the collection policy. So these are built-in collection policies that are required to bring in the audit data from a source into Purview. So the one that we need to turn on for this type of scenario of agents built on Foundry or even Bedrock is the capture interactions for enterprise AI apps. So that's the first step. We do that. Then we go and craft data loss prevention policies. So these are the policies that we can go into and determine what users does it apply to and stuff like that. And this is what we shall now be able to use to do the interventions. So can we block? Do we allow? So this is basically what the policy is about. As you can see, in this case, we have one that blocks the credit card number, the social security number. And that's why when we tried those two prompts, they were not allowed. So that's the policies, and that's a critical.
And you assign that policy to the user, right? Again, not to the agent. Yeah, to the user, because it's on behalf of the user.
Yes.
OBO request. Okay, cool.
Yeah, so you can assign to a group of users, because at the end of the day, you don't necessarily want to build a policy for an individual. So that user can belong to a group. And then this is where you would do it in the administrative units that are defined in Entra, and the user would belong in there. And then that policy would apply to them. Okay, so with that in place, now we can start to see what happens on the data security posture management portal within Purview. So if we go to Activity Explorer and then we go to AI activities, we have a couple of filters here that we can use. So in this case, I'm looking at where the access was done or which app was used, because we have a bunch of events and we want to focus on what's of interest to us. So in this case, it's our expense approval Bedrock agent, and also to simplify it further, I'm focusing on this particular user. So if we go down here, we will see the events that were captured based on the activities that we were taking. So you remember we have tried to submit some prompts that had sensitive information, and indeed they were caught, and we can see that the user who was trying to do that, the type of activity.
The social security number, yes, a sensitive information type.
This is what now the data security posture management allows you to do. You also can see
which policy.
Yes, that was matched. And then the beauty of it is that it doesn't stop there. You can also wire this with Defender such that those alerts also show up in Defender XDR. So here's an example of that. So we can go here to Defender and we look at the incident queue. And here we can see our policy, and we can open it and see the alert. So as you can see, it's not just about Purview and the silo there of data security posture management. The SOC also can get this alert, and they can use that to correlate with other activities that maybe the same user had been taking and build this holistic picture.
So Innocent, all of that, what you showed in Purview, is basically for the data governance person, nothing new, right? So they have these policies for all the other applications that being accessed. So there's nothing that they now need to invent. It's basically you have your rules. Of course, it's managing and maintaining and updating the usual business. But the integration now, that all this existed goodness, how do you say this? The existing goodness can now also be applied on the agents that are rising in an organization. Is just amazing. It's now just up to the organization to enforce the use of Purview, either through, as you said, Foundry, Cluck, Toggle, awesome, but then you're building them in different AI applications. Then make sure they integrate with Purview. I'm amazed.
Exactly. And right there is a benefit that it doesn't matter where you build, so long as you're pointing it to this Purview instance, you get this centralized policy evaluation engine that takes care of all this. So that's really the benefit for both sides, both the data security practitioners and the developers, because they don't have to invest too much time coding for data security on each and every platform they build the agents on.
Exactly.
Yeah.
And how would they all know what's allowed and what's not allowed? Like, that would be nuts. Like, I feel this is wow. But quick question before we wrap that up, Innocent. So you talk to customers all the time, and how are they feeling about getting that implemented? And like, how are you working with them towards a secure and governed AI world?
No, they're really excited about this because, as you can see, the benefit it brings to the developers, that they don't have to worry about coding for various platforms. Coding for data security is actually the challenge itself. Even if you are just doing this in one platform, you would not have to worry about building specifically for data security, which is a huge undertaking, because this is something that Purview has already done. And the other benefit is that, remember, Purview did not just come in yesterday. It's been around for a while, taking care of the classic data security challenges. So these data security practitioners, they're already familiar with Purview. So they are not necessarily going to a course to learn how to govern in this age of AI, because a very short amount of additional skills or knowledge they need to be able to operate in this age of AI. So that's a huge benefit for them. They don't have to relearn a whole new way, a whole new tool, same tool, a few different enhancements, and they are now able to govern in this new age, which is really of big concern to them, because in this age of generative AI, the risks are really being amplified for data loss and oversharing. So they're really excited about this.
That was super exciting, super interesting for me. Innocent, I leave you with a call to action.
All right. So now that we've seen how we can build in not just our native platform, which is Foundry, but also third parties like AWS, what do you do next? Next thing you want to do is to activate the value across these three pillars. So the first thing that you want to do is the discovery aspect. This is where you make sure that Purview audit is turned on. It's usually turned on by default, so you don't have to worry about that typically, but just in case, it's a fundamental step. And then the next thing is to enable the one-click enterprise app collection policies. We showed you that earlier on in the demo, but that is necessary to bring in the events from the agent building platform into Purview. The next is to now go to the data security posture management tool and start to examine what you see there. Are there any gaps that you need to take action around? And then the protection piece is a policy. So now crafting those data loss prevention policies, like we saw in the demo, to actually now prevent those prompts from reaching the model, prevent data loss from actually taking place. So that's an important step. That's what you do under Protect. And you can also have your communication compliance policies that would work similarly to how they do in the world of Teams today. And then the governance piece is really bringing those prompts and responses under the same regime of data lifecycle management, whether it's retention and archiving, allowing you to do things like e-discovery and so on. Again, things that the data security practitioners are already familiar with as they work with classic data. So that's what we ask you to go and do. Govern once, build anywhere, don't sweat it. You have Purview as your central policy engine.
I love it. Innocent, this was a very detailed call to action. I love it. And my call to action is try it out. So, Innocent, thank you so much for being my expert on today's episode. Thanks everyone for watching, and see you soon. Bye.